Okay. We are in example 7 of section 7.8 improper integrals, and here the question is asking me find the values of p for which the integral converges. Now if you look at this integral, you would say we have seen this before. In the last video it was exactly the same, but instead of this one it was infinity and this was 1. And do you remember what should be the answer when this integral converges? Can you just recall? If it is 1 to infinity, you are right, b will be greater than 1. Now we have a different question. Why it's different? Because now I have it from 0 to 1. So let's work it out. Let's evaluate, let's find this integral, and then we will find the value of b. Now this integral is improper of type 2, which is unbounded function. Why it's type 2? Because the function is not defined at 0. Good. So we have to find this integral from 0 to 1 over x to the power of b dx. Now remember, since I have a problem at 0, I need to avoid going to the 0. I'll choose a number a, 1 over x to the b dx, and then I will use the limit as a goes to 0, but it should be a little bit greater than 0 because I go from 0 to 1, something more than 1. I'll keep the limit all the way to the end. And now let me just do this integral. In order to do this integral, I need to write it something like this, and it will be just negative b dx. This integral is easy because x to the power of something, all what you need is to add 1 and you divide by the new power. So it will be x to the power, if you add 1, you get minus p plus 1 over minus p plus 1 from 0 to 1. This is fine as long as I will just write something here, b is not equal to 1. Why b is not equal to 1? Because if b is equal to 1, this will be 1 over x. The answer should be ln x. So now let's forget about b equal to 1. We can deal with it later. And let's do b not equal to 1. The next step we need to do is, I will write this one as this. You will see now why I did that in a second. I will write it as 1 minus p over 1 minus p, just to make things more easier for us. This is a, this is a. Now if you substitute 1, you will get 1 over 1 minus p minus, and then you will do the 0 plus, okay, which is limit a go to 0 plus a to the power 1 minus p over 1 minus p. Now, can we just substitute instead of a 0? If we substitute instead of a 0, the power here must be a positive number. Because if it is negative, everything will go down and then I cannot put the 0 down. So this one must be positive. If you want to continue without problems, 1 minus p should be positive, meaning p is less than 1. In that case, the final answer will be 1 over 1 minus p. So the integral converges if b is less than 1. Otherwise, if this is negative, it would be diverges. Okay. By the same method that I used here, you can prove the p-test that we talked about last time, which is this one. So this is just a side example for your information. Thank you very much.